To produce electric current in the coil, is a magnetic field enough? The answer is no. So can you guess what else is required? I'm sure after watching this video, you will be able to answer it. So here is an experimental setup to explain Faraday's law in a better way. Faraday performed an experiment. He arranged two bar magnets in the shape of a V. At the open end, he kept a soft iron rod with an insulated copper wire wound around it. A galvanometer was connected with this wire. He observed that the galvanometer shows deflection on moving the upper magnet up and down. The magnetic flux linked with the coil becomes maximum when the magnet touches the iron rod. As the magnet moves away from the rod, the magnetic flux in the coil decreases. Faraday observed this and concluded, to produce electric current in a coil, a change in magnetic flux is important and not the flux itself. From the experiments discussed above, Faraday also noted that more current is produced when the speed of the magnet is increased. When a coil carrying electric current is placed below another coil and a relative motion is produced between the two coils, then also the galvanometer shows deflection. If any one of the two coils mentioned above is given a rotation with respect to the other, a deflection is observed in the galvanometer. When a bar magnet is moved closer to a coil in such a way that its north pole faces the coil, the galvanometer shows deflection. In this position, when a bar magnet is moved away, the galvanometer shows deflection in the opposite direction. If the above mentioned experiment is repeated by taking the south pole of the magnet instead of north, the results obtained are similar, but the deflections of the galvanometer are in the opposite direction. Faraday named the current produced as the induced current. When current is generated in the coil, it indicates that EMF is produced in it. Faraday called this EMF as induced EMF and the phenomenon as electromagnetic induction. Let's have a quick recap of what we've learned so far. Faraday observed that a change in magnetic flux induces a current in a coil. This current is known as induced current. The amount of induced current depends on the speed of the magnet. The EMF corresponding to the induced current is known as induced EMF. We are very well aware that Faraday changed the thoughts of the whole world using magnets. Faraday's law involves a magnet and a coil. But did you know how they were arranged and what was the experimental setup? We'll tell you more on that in our upcoming videos.